Okay, so good evening to all. So in today I am going to discuss some of the problems on mesh analysis from chapter 4 of this book, Engineering Circuit Analysis by Hayt Kemmerly. So the first problem that I am going to discuss, it is this. The circuit is given, and using the mesh analysis we need to determine the two mesh currents, means we need to determine the value of I1 and I2. We know that in mesh analysis, simply we first of all we need to write the KVL equation for the two mesh. So we will start writing KVL for mesh I1. So over here, if I start from here, and let me take the convention that if, like over here, if the polarity is changing from minus to plus, then I will minus to plus, then I will take the sign as negative, and if it is changing from plus to minus, then I will take it as positive. Means if I start from this location, then the first of all I will come to this 15-volt battery, and over here the sign polarity changes from minus to plus, means it is this one. So I need to take the magnitude as negative, so I will write minus 15. Now coming to this 9 ohm, over here I1 is flowing in this direction, plus is at the tail, minus at the arrowhead. So now the polarity is changing from plus to minus, means I need to take positive sign, so it will be plus 9 I1. Now after that I will come over here. Now through this 1 ohm resistor we have two currents. One is this I1, and another current that is flowing, it is I2. So I1 is flowing in downward direction and I2 is flowing in upward direction. So it means that effectively over here, the current that is flowing, it is I1 minus I2. I have taken I1 on the left side, means I1 minus I2, not I2 minus I1, because over here we are following this loop current, and as per this direction, means the clockwise direction, the direction of the current is in this direction. So I have taken this I1 minus I2 such that plus sign will be at the top, minus at the bottom, means I will take again this convention. So over here, let me erase the irrelevant things. So over here the current, it is I1 minus I2, plus over here minus at the arrowhead, and following this convention I will write plus resistor is 1 and current is I1 minus I2. After that I will come to this voltage source. Over here the sign change is from minus to plus, so following this I need to take the magnitude as negative, so it will be minus 11 equal to 0, right? So now solving this equation, I will get 9i plus 1i, so it is 10i1 minus I2 equal to, this is minus 15, taking it on the right side I will get 26. So it is our first equation. Now for the second, now applying KVL for mesh I2. Now again I will follow the same convention, this convention. I am moving from here in the direction of the current, means the sign is changing from plus to follow this plus, so it is plus 11. I come to this part over here, I need to see what is the current direction, current in the upward direction. So in upward direction I2 is flowing in upward direction, whereas I1, it is flowing in downward direction. So overall, since I need to consider the current in upward direction, so this time I will take it as I2 minus I1, right? I2 minus I1. So and the polarity, it will be plus at the tail, minus at the arrowhead. So the sign change, it is from plus to minus, same convention. So I will write plus plus 1 is the resistance and I2 minus I1. Now after this, coming to the this 9 ohm, over here only I2 current is flowing, plus over here minus over here, so it will be plus 9 I2. Then coming to this part, sign change is from minus to plus, so minus to plus means we need to consider this one, means I need to take it as negative, so minus 21 equal to 0. Now solving this, simplifying this, so it is minus I1 1 I2 plus 9 I2, so plus 10 I2 and then plus 11 and minus 21, so it is 10 minus 10, and taking minus 10 on the right side I get this. So these are the two equations, and if you solve these two equations simultaneously, you will get I1 as 30 by 11 and I2 will be 14 by 11 ampere. So this is the answer for this question, where we need to determine the two mesh currents. Now going to the second question. Over here it is question number 35 of the book. So over here the question is that we need to choose non-zero values for the 3 voltage source for figure this, so that no current flow through any resistors in the circuit. Right now over here since this particular, let me assume or let me give the nodes with node numbers A, B, C, D and E. So let us assume that let voltage at node B, let it be V1. So if this is V1 and it is mentioned that there is no current flow through any resistor, so it means current cannot flow through any resistor only in one condition, when the polarity, when the node voltage of this B and this D, when they are same, then only the effective current will be 0, means then only current will be 0. It means that if VB is equals to V1, then VD will also be equal to V1, right? Because then only if VD is equals to VB, then only this current will not be there. Similarly for this, if the current given is 0, then it means that VC should also be equal to VB. Similarly for this E, if this current is 0, it means this VE should be equals to VB, means VE it is V1. And similarly for A, that if this current is 0, then it means that VA should be equals to VB, means V1. It means that the all the node voltages including VB should have the same potential, right? Then only there will not be any current. Now if the voltage at this D and voltage at C, if these two voltage are same, right, so it means the voltage over here in this, it should be 0, right? It should be 0. So it means that the voltage of this source S1, it should be 0, S2 it should be 0, and this source it should be 0. So the voltage of all the 3 sources, it should be 0 to have 0 current flowing through all the resistors, right? So this is answer to the second question. Now coming to the third question. Now in this it is given that define 3 clockwise. It is saying we need to define 3 clockwise mesh current for the circuit. So let me define it. Let it be I1. Let this be I2, and let this be I3. And now we need to employ a mesh analysis to obtain a value of H. So we need to determine the mesh loop currents, right? So for this, first what we can do, we can apply the KVL for this loop I1. So KVL for loop I1. So again, following the convention, let me take minus to plus. If the polarity is changing from minus to plus, I will take it as negative. If the polarity is changing from plus to minus, I will take it as positive. We can also take the reverse of it. It will not change the answer. So if I follow this convention, then moving from this point, so when I am at this voltage source, so voltage changes, voltage sign, it is changing from minus to plus. So I will take it as negative, so it will be minus 2. Now coming to this part, I1 is flowing over here, plus sign will be at tail, minus over here, so it means it will be plus to minus. So this one, so it will be plus 2 I1. Then coming to this 9 ohm, again plus will be over here and minus over here, so it will be my plus 9 I1. And then coming to this part, now the voltage polarity is changing from plus to minus, so again plus 1, so it is equal to 0. And now it is 9 plus, okay, we also have this 3 ohm, so it is again only one current is flowing, I1. Tail plus should be at the tail, minus at the arrowhead, so I will write it as plus 3 I1, and this is equals to 0. So over here 2 I1 plus 9 I1, it is 11 plus 3, so it is 14 I1 and then minus 2 plus 1, so it is minus 1, so I will take it on the right side, so it is 1. So I1 is equals to 1 by 14 amperes. Right, now applying the KCL in the second loop, means over here. Now over here you can see, that we have this current source, or let me do it over here. So this is I2, right, and you can see that we have this dependent current source, and the direction, like our I2, it is in this direction, which is in opposite direction to the direction of this current dependent source. So it means that in this particular loop the only current is I2, so we can write I2 is equals to minus of 0.5 Vx, because 0.5 Vx, it is the current that is flowing through this dependent source, and since the direction of the dependent current source, since it is opposite to I2, so I put minus sign over here, right? Now what is Vx? If we look over here, this is our Vx, and to determine the Vx, the loop current is I1, right? So, and in this branch only one current is flowing, and that is I1. As per the direction of the current, plus is over here, minus over here, and since this plus of the current direction and the plus of the Vx, since they are aligned with each other, so it means that our Vx, it will be equals to 9 of I1. So substituting this value of 9 I1 in this, I will get I2 is equals to minus 0.5 into 9 I1. So it is equals to minus 4.5 I1. So I1, what I1 I get? I get I1 as 1 by 14. So substituting this value 1 by 14, so it will be 4.5 into 1 by 14. So So it is minus 9 upon 28 amperes. So our I2, it is minus 9 by 28. Right. Now after this we need to apply the loop current in this, which is I3. Now applying the loop current KVL at loop I3, what we get? Moving from here, if I take minus 2 plus as minus and plus 2 minus as plus. So following this, what I am going to get? So starting with this voltage source, sign is changing from minus to plus. So it will be minus 1. Then coming to this 10 ohm. So the direction tail, we will get positive at the tail and minus at the arrowhead, right? And what is the current? Over here, we through this 10 ohm, we have two currents. One is I3, which is in the same direction, whereas we have I2, which is in opposite direction. So the value of this, it will be I3 minus I2, right? So it means over here the potential drop, it will be plus 10 I3 minus I2. Now after that, coming to this part, over here we have a voltage source and the polarity is changing from minus to plus. So I will take it as minus 5. It is equals to 0. Solving this, we will get, now we already know what is I2, right? So we will get 10 I3 is equals to, this is minus 1 minus 5, so it is minus 6. Taking it on the right side, I get 6. And then 10 I2, so taking it on the right side, I get this. So 10 I3, it is 6 plus 10 I2. Substituting the value of I2, I will get 6 plus 10 minus 9 upon 28, right? So taking the LCM, 28, so 28 into 6 into 8 is 48. It is 10 I3. So 10 I3 is 78 upon 28. So it implies that I3, it is equals to 78 upon 280 ampere. So this is our loop current I3. So with this, we are able to get the loop current of all the 3 loops. So now moving to the second last question, which is problem number 46 from the book. Over here, we need to use the super mesh and we need to obtain the numerical value for each mesh current. So we need to determine the mesh current. Over here, I1 is given, I2 is given, I3 is given, and let this mesh current, let it be I4. So now if we look at this, if we look this loop I1 and I2, over here we have a common current source. So it means that super mesh is formed by loops I1 and I2, right? But if you look at this I1 and I3, then again there is a common current source, and we know that whenever there is a common current source between the two loops, then it means the two loops form the super mesh. So it means that this I1 loop has a common current source with I2 as well as with I3. So it means that we will form a super mesh between 3 loops, between I1, I2 and I3, right? So it means that we are going to write the KVL for this three loops together, right? So now writing the KVL for super mesh. Now what we'll get over here, if we start from, say, and again let me take the convention that minus 2 plus, let it be minus, and plus 2 minus, let it be positive, right? So if I start moving from this direction, from here, now the polarity is changing from plus to minus. So plus to minus, we need to take it as positive, so it is plus 8. Now coming to this part, now over here the polarity of this, it is changing from minus to plus, so I will take it as minus 2 as per this convention. Now coming to this part, only one current I3 is flowing through this, and plus will be at the tail, minus at the arrowhead. So it means moving in this direction, the polarity is changing from plus to minus, so it will be plus 2 I3, resistance into current. Now coming to this part, polarity is changing from minus to plus, so I will take it as minus 3, right? Now after that, when I come to this part, over here there are two currents. One is I2, I2 is going up, whereas we also have this I4, I4 is coming down. So if we want to consider the direction of this current in the upward direction, then we need to take this as I2 minus I4, and plus over here, minus over here, means at the tail we have plus sign, at the arrowhead we have minus sign. 3 is the resistance. It means that polarity is changing from plus to minus, so I will take it as positive. Resistance is 3 and current is this I2 minus I4. Now after this, moving towards this 5 ohm. Now moving towards 5 ohm, plus is over here, minus is over here, so I need to take this polarity is changing from plus to minus, so it is this. So I will take it as plus 5, which is resistance, into current. Now over here, through this 5 ohm, two currents are flowing. One is I1, right? Another current, it is this I4. I4 current is in opposite direction. So since we are taking the direction of the current from right to left, so we will have this magnitude as I1 minus I4, and after that we again reach to this starting position, so it will be 0, right? So solving this, simplifying this equation, what we are going to get? We are going to get, this is 5 I1, second 3 I2, then 2 I3 plus 2 I3, and then minus 3 I4 and minus 5 I4, so minus 8 I4, and then plus 8 minus 2, so it is plus 6, minus 3, so it is plus 3. So plus 3, if I take it on the right side, I will get minus 3, right? Minus 3. Yes. So now this is our first equation. Now for the other equations, how we will get the other equation? If you look, let me erase this. This is our I4, right? So if you look at this I4, now I4 is the loop current, and in this branch I4 current is flowing. Now we have this current source, and this is the only current source, so from this we can get that our I4, it is equals to 3 ampere. Now looking at this current source, Now through this particular branch in which this 1 ampere current source is present, two currents are flowing. One is I2 in this direction, and another current is I1, this I1, which is flowing in this direction, I1, right? So since the direction of the current source, it is from left to right, means the direction of the current source, it is in the direction of I2. So it means we can write that the effective current is I2 minus I1, and the magnitude will be 1, which is the magnitude of the current source in this branch. So this is our second equation. This is our, we can say it is our third equation. And for the fourth equation, if you look at this current source minus 2 ampere, over here two currents are there. One is I3, another is I1, which is in the same direction as the direction of the current source, this one, right? So it means that the effective current that is flowing through this branch in which we have this current source of minus 2 ampere, so the effective current, it will be I1 minus I3, and the magnitude, it will be minus 2. So this will be our equation number 4, right? So over here, let me check if I did everything correctly. Just a minute. Minus 3I2. Yes, so everything is correct. I2 minus I3 is minus 2 minus I3 is okay, correct. So it is correct. So now if you solve these four equations, then you will get the value of I1, it will be 1.4 ampere. The value of I2, it will be 3.4 ampere. The value of I3, it will be 2.4 ampere, and the value of I4, it is 3 ampere. So these are our loop currents. So now with this, we will move to the last question, which is question number 50 in the book. And over here we need to determine the power absorbed by the 10 ohm resistor. So 10 ohm resistor is this one. So again, since over here we have the loops, so we will try to solve this equation with a mesh analysis, right? So to solve this equation with the mesh analysis, what we can do, we will assume the loop current. So let it be I1, let it be I2, let it be I3, and let it be, last one, let it be I4, right? Now applying the KCL for loop I1, what we will get, starting from there and assuming the same convention, that minus 2 change in polarity from minus to plus, I will take the magnitude as minus, and from plus to minus, I will take it as positive. So over here the polarity is changing from minus to plus, so I will take it as minus 4. Over here there are two currents, so at the tail we will have plus, minus, and since there are two currents flowing, one is I1, another is, over here it is I3. So effective current will be I1 minus I3 in this direction from left to right. So I will write plus 3 I1 minus I3, right? After that I will come to this part. So over here the polarity is changing from minus to plus, means I will take it as minus, and the voltage, it is 2IA. So I will put it as minus 2IA. It is equal to 0. It is equal to 0, right? Now solving or 3i1 minus 3i3 minus 2ia, it is equals to 4. This is our equation number 1. Now applying the KCL at for loop 2. Now when I started, if I started applying the KVL, not KCL but KVL for loop 2, then we will stuck over here, because over here we do not know what is the voltage across it. So, and we know that whenever there is a current source in between the two loops, over here the two loops is this I4 and the I2. So there is it forms a super mesh. So we form a super mesh is formed between loop I2 and I4. So it means we will write KVL for super mesh, which is I2, I4, I2 and I4. So what we will get, if I start, let me erase all this, it is this current I1, right? So if I start from here, the polar and in the direction of the current means this. So the polarity is changing from plus to minus, so I will take it as positive, so it is plus 2ia. Now going towards this side. Now over here plus should be over here, minus over here, and there are two currents. One is I1, which is in this direction opposite to this assumed current, right, and I3, which is in the same direction. So over here we will write plus 3 I3 minus I4, I1, so it is I1, right, this is I3. Now after that I will come to this part. Over here only I3 current is flowing, and the plus sign will be at tail and minus at the arrowhead, so it will be plus 10 I4. This is not I3, it is I4. Okay, it is I4. So I need to change this. It is I4. And over here also, and over here I also in this part I have done a mistake. It is I4, not I3, right? So I have changed over here, right? Now let me change this also. It is I4. So it is 10 I4. Now coming from here, I will then come to this 4 ohm. Now in this 4 ohm, one current is I4 flowing in the same direction, whereas one current is in the opposite direction, which is I3. So we will write it as plus 4 I4 minus I3, right? And then after that we will come over here. We will come over here, and over here we have two currents, I2 which is in same direction and I3 which is in opposite direction. So it means we will write it as plus 5 I2 minus I3, right? And then we come over here back to the starting point, so it will be equal to 0. Now simplifying this equation, so we have I1, so it is 3 I1, then I2 5 I2, then I3 we have minus 5 I3 plus this also, so total minus 9 I3. Then I4 we have I4 over here, 3 I4 10 I4, so it is 13 I4 plus 4 17 I4, so it is 17 I4. And after that we left with this plus 2 IA, it is equal to 0. So this is our equation number 2. Now after that, once we get a KVL for super mesh, then we can write the equation for the using the current source that is between the two loops that forms the super mesh. So over here we can see that the current direction of this 5 ampere, it is from left to right, and over here two currents are there. One is I2 in the same direction as the direction of the source, and another is I4 which is in opposite direction to the direction of the source. So over here we can write I2 minus I4 equals to 5. So this will be our equation number 3, right? And now we're left with loop, this I3 loop. We're left with this I3 loop. So over here you can see that we have a current source of 6 ampere, and over here in this branch only one current is flowing, which is I3. So it means that this I3 will be equals to 6 ampere. So we get I3 is equals to 6, which is our, we can say it is our fourth equation, right? Apart from that, we also need to determine the value of IA. So over here you can see this is IA, and the IA, it is exactly same as the I4 because the direction of IA and I4 are same. So it means that our IA, it is equals to I4. So this is our equation number 5, right? So substituting the values of this I3 and IA in the equation number 1, 2 and 3, and solving the equations for the current I1, I2, I3 and I4, we will get our I1 as 4.23 ampere, I2 as 6.74 ampere, I3 as 6 ampere, and I4 as 1.74 ampere. Okay, so let me recheck the if I did everything correctly. Just a minute. So and Mm-hmm. 54, 19, 19 plus 5, 92 minus. Okay, so over here I did a little bit mistake. So over here it is minus 3I1 because over here it is minus I1. So it should be minus 3I1, right? And all the remaining things are correct, right? So after solving this, we will get I1, I2, I3, I4 as this. Now as per the question, what we need to determine? We need to determine the power absorbed by the 10 ohm resistor, means this one, right? So over here the current is I4, right? Because we have assumed the loop current as I4. So it means this current, it is 1.74 ampere. So the power over here, it will be I square or I4 square into resistance, which is 1.74 square into 10, right? And if you solve this, you will get answer as 30.276 watt, and this is plus because over here we need to determine the power absorbed, right? And since it is a resistor and the current is flowing in this direction with plus sign over here, minus over here, and we know that if the current is entering the positive terminal, so it means that the element is absorbing the power, and if it is asked power absorbed, so it means it should be positive. So this is our answer to the 5th question. So with this I end this video. If you have any doubt, you can put it in a comment box, and do subscribe my channel and like the video if I am able to clarify your doubts. So thank you.